All right, so 4, 4. So it's pretty obvious what it says. What two triangles can we show congruent? So it's going to be that triangle ABD is congruent to that triangle. That's what we're going to try to prove. Okay. And in order to do that, we need to know angles. We need to know sides. We need to know different parts. Okay. So I like the statement reason proofs. I think they're just kind of easier to work with than the flow. I honestly think that if I gave you if I gave this to you on the test, this particular one or any one, that I don't care how you do it, but I think you're going to be better off doing statement reason. I'm going to yesterday we were kind of asked the question, does the order matter in how we do this? So the order doesn't necessarily matter. So I'm going to go ahead and just go angle 1 is congruent to angle 4. Okay? So angle 1 is congruent to angle 4. And how did I know that? Because it's given. And I can tell you that almost every single time, whatever's given, you need to include in your proof. Okay? So right off the bat, I have an angle. Then they tell me that angle ABC is 90 degrees and angle CDA is 90 degrees. So ABC and angle CDA, 90 degrees. I don't like making that on two spots, but
why do we need to write that if it goes through the other triangle? It says ABC, which goes through both triangles.
Right. So we're gonna use that.
So since you know it's 90 degrees, could you say something how B and C and A and B are parallel? Yeah.
Maybe.
Could you say that it has to be directly the same angle? So if they're both 90 in the corner, then
there's definitely more than one way to prove this. I would not go into parallel lines myself. Okay, doesn't mean it's wrong. Okay, so we can say that these lines are parallel because of angle 1 and 2 or angle 1 and 4. Okay, and then and then you're talking about these lines being parallel. Okay, and we can get into proving that. I think there's an easier way. Do you want me to use parallel lines or the way I'm thinking? Okay, so I know that angle 1 plus angle 2 equals 90 degrees. Okay, yep, complementary angles. And angle 3 plus angle 4 equals 90 degrees. I don't know why I'm abbreviating complementary angles like that. It's kind of weird, but doing it. And then I know, because I know that, so then I know that angle 1 plus angle 2 equals angle 3 plus angle 4. That's substitution. And that's why I wanted to play that reason game the other day, because you kind of have to be able to, throughout the year, use all these different reasons.
What was the reason?
The quizzes we did where you had to pull out. Okay. And if angle 1 is congruent to angle 4, okay, then I can, I don't know, I can substitute this.
Angle 1 plus
Angle 2 equals
And then angle 2 equals angle 3. subtraction. Be careful here. I can't just put sub. I gotta put subtraction.
Sub. Put sub with a T.
Okay.
I'll just throw out the word subtraction.
I think if it's your notes, maybe we can abbreviate. If it's a test, maybe we don't. So I just showed that this angle is congruent to this angle. And then I can say that angle or side BD is congruent to BD.
That is
Reflexive.
Reflexive? Yep.
Yeah.
Okay.
BD is equal to BD?
Yep.
But that's like common sense.
A lot of this is common sense. So you got to write it down though, because I had to write down. So now I have an angle, two angles that are congruent, two angles that are congruent, and a side that's congruent. So now I've done everything that I can do or need to do in order to now say what?
Triangle. ABD.
ABD, and somebody got upset because they named the triangle right, but they named it in the wrong order. A corresponds to what? C, so that's got to be the first letter. B corresponds to D as in dog. Because see that this angle is congruent to that angle. And then finally, C, D, B. Careful.
No,
Angle.
It's angle, side, angle. Now, yesterday I said the order of these things don't matter, but it's angle, side, angle, because if we look at the triangles, it's angle, then we're given the side, and then we're given the angle. Yeah, welcome to geometry.
I don't want to be here.
Okay. Well, then you're not one.
Yeah, I should
Yeah.
It's not true. I should drop out. That's still
I think McDonald's is hiring.
I will buy
Wait, you?
Actually, I'm gonna go be a pizza.
That'd be important.
They're offering $20 an hour.
Yeah, you have a driver's license?
When I get a job.
Ah.
I guess that's true.
Hey, guys, like to
I'm going to be an engineer.
18.
I was gonna do fours.
Mr. McConnell, I'm so happy. All my friends are gonna be in bug seats.
All right, so number 3. Okay, so it says a flow proof. A flow proof is exactly the same thing, except when I finish this statement reason, I put a comma, and then I put this next line. And then I put a comma, and then I put this next line. So a flow statement proof has the exact same words. A flow proof doesn't have to be complete sentences. It could have arrows. I mean, so it has the this, then this is this, and all that stuff. It doesn't really. The flow proof is just you just write the stuff out. Okay. In my opinion, it's like I ate this for lunch, this nice written proof, and then I threw it up on the paper. That's how I hate flow proofs. Okay.
We didn't read the directions. We did not do it.
Okay. Don't know. Say again. Okay. You have to know flow proofs because if they're on the test, you have to not freak out because it's a flow proof. And I'm talking about the end of course test at the end of the year. But they're exactly the same. Okay? So please, yeah. I've been asked to do 3, so I'm going to do 3 and then I'll do 4. Okay? So I'm guessing I can prove either these triangles congruent or the ones across from each other. Okay? It says which one, name two that you can prove. JL bisects. Okay, so we're told that if it bisects, then what's true about this angle and this angle?
They equal 90.
No,
They are parallelogram.
they're congruent.
They are parallelogram.
Okay, if you cut something in half, then those two halves are equal.
Yeah.
But it doesn't necessarily mean that this is the same as this across from it.
Right.
Okay, and KM bisects. So this, so I got to do 3 here. And then this, I'm just going to make it bolder, is congruent to that. So I think the easiest, I'm going to actually just, the big triangle is one that I'm going to prove congruent. So I'm going to prove triangle JKL is congruent to triangle LMJ. And we're going to run out of time, but we'll sneak the rest of these in tomorrow's notes.